Dear students, so in module 4, the next topic which we are going to study is two topics we are going to study in this video, that is stream pipes and passing file descriptor. So what is stream pipes? So a stream pipe is a bidirectional full duplex pipe. Already we had studied the pipe. So pipe, what it was? Pipe limitation was that it was half duplex. Means half duplex means data can be transferred from one end to another end. From another end, data cannot be received to the first end. So, but in the stream pipe, it is a full duplex. So, data can be transferred from process A to process B, and data can be received also from process B to process A, both the direction. So, to obtain bidirectional data flow between a parent and a child, only a single stream pipe is required, like here. So both the direction, like if using FD0, data can be sent to FD1, and FD1 can also send the data to FD0. Similarly, you can see here, so here it is a stream pipe. Data can be written from FD0 to stream pipe, and data can also be read from stream pipe to FD0. Similarly, using FD1, data can be written to stream pipe, and data can also be written to FD1 to the process. So both the direction data can be transferred. Now, for example, if we look inside a stream pipe here, we see that it is simply two stream heads with each write cube pointing at the other read cube. Now here, suppose this is stream head and it has write cube and read cube, and another it is also write cube and read cube. So this is for FD0 and FD1. So in FD0, the write cube will read queue will read the data from W queue, and FD0 read queue will read the data from FD. Means data can be written, it can be read by FD0 also, and it can also be read by FD1 also. So data written to one end of the pipe is placed in messages on the other read queue. Now, to create a stream pipe, we use this prototype integer s underscore pipe integer file descriptor 2 and return pipe fd. So here also it returns two file descriptor. So file descriptor 0 and file descriptor 1. So the next topic which we are going to study is the passing the file descriptor. How to pass the file descriptor from one process to another process. The ability to pass and open a file descriptor between processes is powerful. So it can lead to different ways of designing client server application. So this is very important and powerful method, uh, passing file descriptor. So it allows one process to do everything that is required to open a file and simply pass back to the calling process a descriptor that can be used with all the input output functions. So generally passing file descriptor is nothing but it allows one process, and generally it is a server, to do everything that is required to open a file and simply pass back to the calling process a descriptor that can be used with all input output functions. So whenever we call open API to open a file, So Open API will open a file and it will pass the file descriptor to the calling process. Open API will return a file descriptor to the calling process. So all the details involved in opening the file or device are hidden from the client. All the details involved in opening the file or device are hidden from the client. All the complex things will be hidden from the client. When we pass an open file descriptor from one process to another, we want the passing process and receiving process to share the same file table entry. For example, whenever you want to pass uh, uh, an open file descriptor from one process to another, for example, here one process want to send the file descriptor to another process. Now both the process will have the process table entry. So process table here and process table here, and they all will share the same file table. So here file table is there. So all one is receiving, another is sending. So here file table which they will share is file status flag, current file offset, and v node pointer. So here node pointer, it will hold the address of another v node table. So v node table, v node information, I node information, and current file size. So all the things will be there. So the if suppose this process wants to send the file pointer to this process, so they have to share the same file table and both are pointing the same thing. So what all of functions can be used for sending the file pointer? Technically we are passing a pointer to an open file table entry from one process to another process. You can see that here we are sending the pointer from one process to another process. So this pointer is assigned the first available descriptor in the receiving process. So it will be assigned the first available in the receiving process table. We define the following three functions and we use in this chapter to send and receive the file descriptor. What are the functions we use to send the file descriptor is integer send underscore fd, integer file descriptor, integer fd underscore to send. Next, integer send underscore error, integer fd, comma, integer status, comma, const char star error message. And both returns 0 if okay and -1 on error. So both return 0 if the file descriptor is sent and -1 on error. Next one, integer receive underscore fd, integer fd, comma, s size underscore t, star user function, integer const void star comma size underscore t. So this function is used to receive the file descriptor. This function is used to send the file descriptor. If any error occurs, then this function send error is used. So for receiving, file descriptor will be received if okay and negative value will be sent on error. A process normally a server that wants to pass a descriptor to another process, it will call send underscore fd or send underscore error. These are the functions they use the process if they want to send the file descriptor. The process waiting to receive the descriptor calls receive fd. So if the process wants to receive the file descriptor, it will call receive fd. To send error, to the send underscore error function sends the error message using fd followed by the status byte. The value of status must be in the range 1 through 255. Clients call receive underscore fd to receive